Hello students and welcome. In this video we're going to go over section 3.2 on conditional probability and the multiplication rule, and we will also look at some problems from the homework. We use the multiplication rule to calculate conditional probabilities, which are probabilities that involve two events, where the first event that occurs is the given event, and the given event usually has an effect on the probability of the second event. We also use the multiplication rule to calculate the probability of two or more events that occur in sequence. So what that means is if you have two or more events that happen in sequence, that means that one event happens after the other. So you have the first event followed by the second event, and if there's more events after that, then you have the third event and so on. So let's go over some important notation in this section. So this notation right here stands for the probability of A given B. Okay, so the capital P here stands for probability, and whenever we see a set of parentheses next to the capital letter P, right, we're going to throw the word of in there. So this means probability of A given B. So the line that separates the two events is read as given, so it means given. Okay, so this notation means probability of B given A, and that's what it stands for. Okay, it's important to know that the probability of A given B and the probability of B given A are not the same. And in some cases, the probability of A given B is equal to the probability of A, right? Or the probability of B given A is equal to the probability of B, all right? And that happens when the given event does not have an effect on the probability of the occurrence of the second event. Okay, so when you see this notation, the given event always comes after the line. Okay, and then the second event comes before. So it looks a little backwards, but it's not. So the way that you read it should make sense. So the probability of A given B. So the given event here is B, which means that B occurred before A and has an effect on event A. Okay, likewise, probability of B given A. So the given event here is event A, which occurs first, okay, followed by event B. Okay, so probability of A given B is equal to probability of A or probability of B given A equal to B, right? Only when the two events are independent. And you can see the definition of independence of two events on page 148. Okay, let's go and look at some examples from the homework. Okay, and the first question asks, what is the difference between independent and dependent events? So I would encourage you to review the definitions of independent and dependent in the book. So I'm going to go ahead and skip over this question. Okay, and we just went over this in the first part of the video, right? So what does the notation mean? Okay, so since we already went over that, I'm going to go ahead and skip question 2. All right, let's go ahead and take a look at question 3. And the problem says that two cards are selected from a standard deck of 52 playing cards. The first card is not replaced before the second card is selected. So in other words, once we take that first card, we do not put it back into the deck. So the question is, find the probability of selecting a 4 and then selecting a 9. Okay, so a standard deck of playing cards has 52 cards. So each deck has 4 suits, clubs, spades, hearts, diamonds, and there are 13 cards in each suit. And the important thing is that the 2 cards are selected without replacement. So what that means is that once you take the first card out, that's going to affect the probability of whatever the second card is. Okay, so let's say, for example, that we select a card, a 4 on the first try. Okay, so let's count how many 4s there are. So there are 1, 2, 3, 4 4s. okay, out of a possible 52 cards. Okay, so the probability of getting a 4 on your first selection, okay, is going to be 4 out of 52. Okay, so we can write that as a fraction, so 4 out of 52. Okay, so then once we select that 4, whatever 4 it is, right, we take it out of the deck. Okay, so now we have one fewer cards to select from. So now instead of 52 cards, we have 51 cards to choose from on our second pick. So now we want to know the probability of selecting a 9 right after we have selected a 4 and taken it out of the deck. Okay, so there are 1, 2, 3, 4 9s in the deck. Okay, so the numerator is going to be 4 because we already took out the 4 that we've chosen. Right, now it's out of 51 instead of out of 52. So the multiplication rule suggests that we multiply these probabilities because these two events occur in sequence, right? Selecting the 4 first, followed by the 9. Okay, so on our calculators, we're going to do 4 out of 52. So 4 divided by 52, okay, multiplied by 4 divided by 51. Okay, and we're going to get that number there. That represents the probability. Okay, and we're going to round that to 3 decimal places, so it's 0.006. Okay, let's look at question 4, and it says that in a sample of 1,100 U.S. adults, 207 think that most celebrities are good role models. It then says 2 U.S. adults are selected from this sample without replacement, and we're going to complete parts A through C. Okay, so once again in part A, we're finding the probability that both adults think most celebrities are good role models. And remember that we're selecting the 2 adults without replacement. Okay, so when we select the first adult, we want to know that the probability that the first adult thinks that celebrities are good role models. Okay, so the probability that the first adult thinks has that belief, right, would be 207. Okay, so there are 207 adults out of the 1,100 who have that belief. Okay, so it'd be 207 over 1,100. Okay, so what about the probability of selecting another adult with the same belief? So if we take the first adult out, who has that belief, right? That means that there are 206 left, right? And then instead of 1,100 as the total, we have 1,099. All right, and multiplying those two fractions together will give us our probability. So 207 divided by 1,100, okay, multiplied by 206 divided by 1099. Okay, so to 3 decimal places, that's 0.035. All right, and if you'd like to, you can convert that into a percentage. So to go from a decimal to a percent, you move the decimal point 2 places to the right. So it's about a 3.5% chance that if we select 2 adults without replacement from this the sample of 1,100 adults, right, we're going to get 2 adults who believe celebrities are good role models. So let's go ahead and input our answer. So we're going to input it as a decimal, so 0.035. Okay, part B says, find the probability that neither adult thinks most celebrities are good role models. Okay, so let's take a moment to think about this, right? So if 207 out of the 1,100 believe that celebrities are good role models, right, then how many out of the 1,100 do not have that belief? Okay, so to get that number, right, we can do 1,100, okay, which is the total, minus the 207, who have the belief that celebrities are good role models. All right, and then that number there, 893, is a number who do not believe celebrities are good role models. Okay, so for the first adult, okay, so the fraction representing the probability for the first adult would be 893 out of 1100. Okay, once again, we're making our selection without replacement. Okay, so the probability that the second adult also has that belief that celebrities are not good role models. Okay, this should say are not good role models, right? Would be 892 out of 1099. So a very similar calculation as in part A. Okay, let's go to input that into your calculators. So 893 out of 1100 multiplied by 892 divided by 1099. Okay, so it's a much higher chance, so 0.6589. Okay, so rounding to 3 decimal places, that 8 will get rounded up to a 9, so 0.659. Okay, which if you convert that to a percentage is 65.9%. Okay, some people understand percentages better than decimals, so it's a little more than a coin toss, a little better than a coin toss. Okay, but in any case, our answer that we input to my stat lab is 0.659. Okay, so part C says find the probability that at least one of the two adults thinks most celebrities are good role models. Okay, so part C we have to think about a little bit. So let's go to the book. Okay, and there should be a section in section 3.2 that talks about how to find the probability of at least one. So let's go ahead and find that section. Okay, and there's an example on page 150 that's very similar to the one that we're doing right now. So at the bottom of that page, it says in example 4, you were asked to find the probability using the phrase at least one. So notice that it was easier to find the probability of the complement, which is none. Okay, so you can think of the word complement as meaning opposite. So the opposite of at least one, right, is none. So remember, at least one means one or more. Okay, so the opposite of at least one, the opposite of one or more is none. Okay, so in other words, you find the probability of none, and then subtract that probability from one. Okay, and that's what this formula is communicating. So if you're asked to find the probability of at least one of an event, right, that's equal to 1 minus the probability of no occurrence of that particular event. So if we go back and look at our previous answers, right, we see that in part B, we've already calculated the probability that none of the adults believe that celebrities are good role models. Okay, so using the formula at the bottom of page 150, okay, it says that the probability of at least one is equal to 1 minus the probability of none. Okay, so we already know the probability of none. Okay, we calculated that in part B. Okay, that's just, so it's, the answer then would be 1 minus 0.659. Okay, so my calculator is 1 minus 0.659. Okay, is equal to 0.341. Okay, or about a 34.1% chance that out of the two adults we select, right, at least one of them hold the belief that celebrities are good role models. Okay, but the answer that we put into the problem is 0.341. All right, and we've completed question 4 from the homework. So in the next video, we'll go ahead and do more examples from section 3.2 in the homework. Thank you for watching.